Motion of center of mass of system of particles. Let's consider we have a system of two masses. First mass is called big block, and it is this box with mass m1. So m1 is a mass of the big block. There is second element of the system of particles is smaller, and the mass is denoted m2. It's a mass of small block. And we will investigate the motion of the center of mass of big block and the center of mass of small block using the knowledge we got earlier. So let's denote also initial position of big block. So it's a position at time equals 0. x2 0, it's an initial position of small block. So somewhere here in this space, in this direction, there we could measure xt0. I don't draw it here. And let's consider that small block can make motion relatively to big block. And the principle of motion is that there is, for example, piston which is operated by pressurized gas or anything, and this piston is moving in this time course A. What is amplitude of motion of small block? Because this small block is moving in the same way as the piston, by sinus omega t, where omega is angular velocity of circular motion, so it's a periodic motion with angular velocity omega. So it oscillates like this, and therefore the small block is oscillating in the same way. Okay? And the task is to calculate the absolute motion of big block and small block to find x1 depending on time and x2 depending on time. So it means these are these two distances, okay? Distance of this point and distance of this point in time. For if we can calculate the center of mass of this system of particles, we can use the static equations of motion. So we can say that at 0 time the position of center of mass was xc0. Okay, so somewhere here, because we know that the center of mass must be on this straight line between c1 and c2. Okay, so let's say here, because mass m1 is greater than mass 2. So using statical equation of moments, we can write that m1 plus m2 by xc0 is equal to m1 by x10 plus m2 by x20. It's an equation of statical moments. So statical moment of all system is the same as the sum of statical moments of system elements. So this is general equation. So from this equation we could express the original position, it means in time equals 0 at the beginning of the process, of the center of mass. So from this we could calculate xc0. if the time is not equal 0, so in general time we can make a similar equation, but xc position of center of mass is no more the beginning or origin for time 0, but its general position. So xc, so general position of center of mass by total system mass, is equal to sum of moments, statical moments of system elements. So it's m1 by x1 plus m2 by x2. And from this we could calculate the position of center of mass of the system, of all system, in time, generally. But last time, from last lecture, we know that, for example, let's see to this image, there are some particles, and this system of particles has some center of mass, and this is a position xc of center of mass. Yeah. And if there is no external force, we can use the knowledge we got last time. So it's a law of motion of center of mass of a system of particles, and it says that if there is no external force, this, even if elements of system are moving, the center of mass stays at the same position, so it's constant, even if there is motion of these particles. So we can apply it, and so we can conclude that xc0 is xc. If xc0 is equal xc, so this left side of equation is equal to this left side of another equation. If we have two equations, 1 and 2, and left sides are equal to each other, so that right sides of equations must be equal to. So from this we can deduce that there is a new equation, so this is equal to this, and I create new equation number 3. But still we have only one equation for two unknowns. The unknown is a general motion of small block and big block, and general motion of small block x1 and x2. So I need another equation. We can write it from geometry, okay, of motion. So if we look above, and we can write the general motion of small block. So it's an initial position of small block at time 0 plus something, plus relative motion of mass 2 related to mass 1. So it moves about a by sinus omega t to the right. Okay, so there is plus something, plus some relative motion of m2 regarding m1 about this value. But if we know that center of mass keeps the same position and mass m2 is moving right, so big block m1 must move left. So I need, and all system is going back, so then I need to subtract this part. So big block moved about this to the left, okay, to this direction, left. Okay, so please try to think about it. I hope you will understand it. So now we have two equations, 3 and 4, for two unknowns, x1 and x2. And it is very simple to solve it. For example, by substituting 4 into 3. If we do it, so we have originally we have this equation and we are substituting for x2 here. Yeah, so we put all this expression instead of x2. So we continue like this. So there is this from this side, it's a left side of equation, and we continue. We are copying m1x1 from here and m2 by, and we multiplying this. So it is m2 by this, m plus m2 by this, minus m2 by this, plus m2 by x1. And slowly we can calculate x1 putting this, oh sorry, no, this and this together, putting x1 out of the brackets and put it to the left side of equation, and all other terms we put to the right side of equation. So this and this we put here, x1 out of the brackets, and is equal, and rewrite everything what rests there. Okay, and from this we get the equation for x1, that it is x10 minus something m2 over m1 plus m2 by, and so also x2, we can calculate x2, that it is equal this. So we can say that at the time equal to time 0, so there remains only these terms. So when we draw the graph, so at time equals 0, we have initial positions for small block and big block. And if we observe the motion of small block, for example, if m1 is greater than m2, so big block makes motion with smaller amplitude, because if m2 is small, so that this fraction is small too, and if m1 is big, so this fraction is big too. So big block moves with very small amplitude because it's heavy, and small block is moving with very big amplitude because small block is very light. When we draw these time courses in this graph, so there is a motion of small block, and there is a motion of big block. Okay, so small block is going right, and then it's oscillating. Okay, small block is going right and is oscillating in time, and big block is going left when small block is going right, and is moving opposite, in opposite direction. So if small block moves right, big block moves slightly left. So it moves like this, where pencil is a big block. Okay, big block has a very small amplitude and the direction of motion is opposite to the small block, which has a very large amplitude. So like this. And this type of motion keeps the law of constant center of mass of all system. It means small block and big block together. So this law keeps the center of mass of the system. The system is made by M2 and M1, so it is constant. This doesn't move because there is no external force.